Assalamu alaikum. Myself Momi Mohammed and my ID number is 1923547. Today I am presenting my assignment topic. It's about single round of DES and its implementation. Okay, first I am discussing about what block cipher DES algorithm diagram. In this diagram, we can see the 64-bit plain text will convert it into 64-bit cipher text. So for this purpose, we can assume some round. First, in 64-bit plain text, we permutation it initially, then we going into a round 1. After going into a round 1, we sequentially happening round 16, up to round 16. After round 16, we swap our 64-bit. First 32-bit, it means right 32 bits is going to left and left 32 bits going to right. By 32-bit swapping, we again permutation our initial inverse permutation. Then we can finalize our 64-bit ciphertext. So by this round, we also need some 64-bit key. So for 64-bit key, we should uh, permutation choice and remove the 8-bit and going into a 56-bit key. After going a 56-bit key, we can see a left circulation shift, and by doing left circulation shift, we can assume the permutation choice 2. By permutation choice 2, we can see our 56-bit key is going into a 48-bit key. Okay, so eventually this is happening in round 1 to round up to round 16. So what is in the round 1, and this is the single round of DES. Single round of DES is about 64-bit key is divided into two sections. It's 32-bit and 32-bit. First 32-bit left section is going into a right section XOR operation, and 32-bit right section is first expand permutation. By expanding permutation is going into a 32-bit key is going into 48-bit. 32-bit plain text going into 48-bit. And this 48-bit plain text and the 48-bit key will get XOR operation. So how this 48 key is we can get? So in the 64-bit key, we get, by permutation choice we get 56-bit. So for this, we in this section we divided the 56-bit key into two sections, what is 28 bits and 28 bits. By this section and left circulation shift, we can achieve this compressed key and 48-bit key. By 48-bit key and the 48-bit plain text, we got a XOR operation, and in XOR operation, after the XOR operation, we make it S box conclusion. S box means where the six where the six where we give the input 6 and output is 4. So in this section we get 48-bit plain text, and as when we give into this S box give us the 32 bits. So by S boxing and permutation, also XOR operation, we can get our a ciphertext. So what is happening in the single round? By implementation, we code it in Python in PyCharm environment. So first I input a text in a hexadecimal number. In hexadecimal number, uh, I format this in binary, and by formatting this binary, I return this text. After returning text, I initialize the permutation. So for the permutation access, we can see here this left circulation left side LRT is in 32 bits and RT is in 32 bits. So for this 1 is to 32, it means is to 32 first bit to 32 bits, and 32 is to gap, it means 32 is to 64 bits. So in left hand side first to 32 and right 32 into is to 64 bits. By returning this L and LRT and RRT, we can going into a key replacement. Again, we divide it into two sections in C and D, and there first to 28 bit is going into C and 28 to 56 bit is going to D. After this, we get into this return value. Okay, then we compress our key. What is compression of key? Compression of keys when we divided this C and D, and after left circulation shift, we again compressed it and permutation choice. So that's the thing. Key equal to 6 plus D, and new key called by array. We can uh, continue a loop by for loop. After the for loop, we can add or append some key. Then we initialize a new key, and after initializing new key, we return this key. So here is the process of key compressed, key replacement, and IP. So then we this implement we can generate our key set by appending C equal to key left rotate and C equal to K left rotate. It means left circulation shift, and after append this K, then we we can go into a our next phase, that's the expand permutation. So by expand permutation, we define our R expand, and as a parameter we set it as R, and our newer is new bit after going into 32 to 48. So for this we again continue our for loop for one purpose, then we make our new R. After initialize our R, we also return our R. Okay, then 48-bit key and 48-bit plain text is going into XOR operation. So for this we make two parameters as input 1 and input 2, but for this XOR result, and for I in range is 0 to len input 1, and XOR result dot append equal to int input 1 into input 2I. So this is our XOR result returning. After returning this XOR result, we make the SBox system by going to for loop. So SBox system where two side of bit is select as row and a middle bit of is select as column. So here we define this row and column, and after this we can see our result, and calculating our result we return our SBox results. So here is the process of substitution, and by substitution we declare a function, and the function will go to our encryption process. So in this encryption process, we all generate our XOR operation, permutation choice, and also our the substitution choice. All input is here, and after this permutation and XOR operations, we get our output file CFR, and this is CFR text, our final and return. So whole process is going into single round. So we make it into a single round, also a input file. So here is our input file. So if we run it, say run. Okay, terminal, terminal, sorry. So enter message. Moni Ahmed. Here is our going to a plain text. Hello, myself Muni Ahmed, and our cipher text going into some bytes. So here is my single round of DS code implementation. Thanks a lot.